Smalltalk is an object-oriented, dynamically typed, reflective programming language. Smalltalk was created as the language to underpin a new world of computing exemplified by human-computer symbiosis. It was designed and created, in part for educational use, more so for constructionist learning, at the Learning Research Group of Xerox PARC by Alan Kay, Dan Ingalls, Adele Goldberg, Ted Kaehler, Scott Wallace, and others during the 1970s. The language was first generally released as Smalltalk 80. Smalltalk-like languages are in continuing active development and have gathered loyal communities of users around them. ANSI Smalltalk was ratified in 1998 and represents the standard version of Smalltalk. History. There are a large number of Smalltalk variants. The unqualified word Smalltalk is often used to indicate the Smalltalk 80 language, the first version to be made publicly available and created in 1980. Smalltalk was the product of research led by Alan Kay at Xerox Palo Alto Research Center. Alan Kay designed most of the early Smalltalk versions, which Dan Ingalls implemented. The first version, known as Smalltalk 71, was created by Kay in a few mornings on a bet that a programming language based on the idea of message passing inspired by Simula could be implemented in a page of code. A later variant actually used for research work is now known as Smalltalk 72 and influenced the development of the actor model. Its syntax and execution model were very different from modern Smalltalk variants. After significant revisions which froze some aspects of execution semantics to gain performance, Smalltalk 76 was created. This system had a development environment featuring most of the now familiar tools, including a class library, code browser, editor. Smalltalk 80 added metaclasses to help maintain the everything is an object paradigm by associating properties and behavior with individual classes, and even primitives such as integer and Boolean values. Smalltalk 80 was the first language variant made available outside of PARC, first as Smalltalk 80 version 1, given to a small number of firms and universities for peer review and implementation on their platforms. Later a general availability implementation, known as Smalltalk 80 version 2, was released as an image in a virtual machine specification. ANSI Smalltalk has been the standard language reference since 1998. Two of the currently popular Smalltalk implementation variants are descendants of those original Smalltalk 80 images. Squeak is an open-source implementation derived from Smalltalk 80 version 1 by way of Apple Smalltalk. VisualWorks is derived from Smalltalk 80 version 2 by way of Smalltalk 82.5 and ObjectWorks. As an interesting link between generations, in 2001 Vasily Bykov implemented Hobbes, a virtual machine running Smalltalk 80 inside VisualWorks. During the late 1980s to mid-1990s, Smalltalk environments, including support, training and add-ons, were sold by two competing organizations, PARC Place Systems and Digitalk, both California-based. PARC Place Systems tended to focus on the Unix, Sun Microsystems market, while Digitalk focused on Intel-based PCs running Microsoft Windows or IBM's OS/2. Both firms struggled to take Smalltalk mainstream due to Smalltalk's substantial memory needs, limited runtime performance, and initial lack of supported connectivity to SQL-based relational database servers. While the high price of PARC Place Smalltalk limited its market penetration to mid-sized and large commercial organizations, the Digitalk products initially tried to reach a wider audience with a lower price. IBM initially supported the Digitalk product, but then entered the market with a Smalltalk product in 1995 called Visualage Smalltalk. Easel introduced Enfin at this time on Windows and OS/2. Enfin became far more popular in Europe, as IBM introduced it into IT shops before the development of IBM Smalltalk. Enfin was later acquired by Syncom Systems, and is now sold under the name Object Studio, and is part of the Syncom Smalltalk product suite. In 1995, ParkPlace and Digitalk merged into ParkPlace Digitalk and then rebranded in 1997 as ObjectShare, located in Irvine, CA. ObjectShare was traded publicly until 1999, when it was delisted and dissolved. The merged firm never managed to find an effective response to Java as to market positioning, and by 1997 its owners were looking to sell the business. In 1999, Seagull Software acquired the ObjectShare Java Development Lab, and still owns Visual Smalltalk, although worldwide distribution rights for the Smalltalk product remained with ObjectShare, who then sold them to Syncom. VisualWorks was sold to Syncom and is now part of Syncom Smalltalk. Syncom has backed Smalltalk strongly, releasing multiple new versions of VisualWorks and Object Studio each year since 1999. Syncom, Gemstone and Object Arts, plus other vendors continue to sell Smalltalk environments. IBM has, and developed Visualize Smalltalk, having in the late 1990s decided to back Java, and it is, as of 2006 update, supported by Instantiations, Inc., which has renamed the product VA Smalltalk and released several new versions. The OpenSqueak implementation has an active community of developers, including many of the original Smalltalk community, and has recently been used to provide the Etoys environment on the OLPC project, a toolkit for developing collaborative applications Croquet project, and the Open Cobalt Virtual World application. GNU Smalltalk is a free software implementation of a derivative of Smalltalk 80 from the GNU project. Faro Smalltalk is a fork of Squeak oriented towards research and using commercial environments. A significant development that has spread across all current Smalltalk environments is the increasing usage of two web frameworks, Seaside and IDA Web, to simplify the building of complex web applications. Seaside has seen considerable market interest, with Syncom, Gemstone and Instantiations incorporating and extending it. Influences. Smalltalk was one of many object-oriented programming languages based on Simula. Smalltalk was also one of the most influential programming languages. Virtually all of the object-oriented languages that came after, Flavors, Clo, Objective-C, Java, Python, Ruby, and many others, were influenced by Smalltalk. Smalltalk was also one of the most popular languages with the agile methods, rapid prototyping, and software patterns communities. The highly productive environment provided by Smalltalk platforms made him ideal for rapid, iterative development. Smalltalk emerged from a larger program of upper-funded research that in many ways defined the modern world of computing. In addition to Smalltalk, working prototypes of things such as hypertext GUIs, multimedia, the mouse, telepresence, and the Internet were developed by upper researchers in the 1960s. Alan Kay also described a tablet computer he called the Dynabook, which resembles modern tablet computers like the iPad. Smalltalk environments were often the first to develop what are now common object-oriented software design patterns. One of the most popular is the Model View Controller pattern for user interface design. The MVC pattern enables developers to have multiple consistent views of the same underlying data. It's ideal for software development environments, where there are various views of the same underlying specification. Also, for simulations or games where the underlying model may be viewed from various angles and levels of abstraction. In addition to the MVC pattern, the Smalltalk language and environment were tremendously influential in the history of the graphical user interface, and the what you see is what you get user interface, font editors, and desktop metaphors for UI design. The powerful built-in debugging and object inspection tools that came with Smalltalk environments set the standard for all the integrated development environments. starting with Lisp machine environments that came after object-oriented programming. As in other object-oriented languages, the central concept in Smalltalk 80 is that of an object. An object is always an instance of a class. Classes are blueprints that describe the properties and behavior of their instances. For example, a GUI's window class might declare that windows have properties such as the label, the position, and whether the window is visible or not. The class might also declare that instances support operations such as opening, closing, moving, and hiding. Each particular window object would have its own values of those properties, and each of them would be able to perform operations defined by its class. A Smalltalk object can do exactly three things: hold state, receive a message from itself or another object. In the course of processing a message, send messages to itself or another object. The state an object holds is always private to that object. Other objects can query or change that state only by sending requests to the object to do so. Any message can be sent to any object. When a message is received, the receiver determines whether that message is appropriate. Alan Kay has commented that despite the attention given to objects, messaging is the most important concept in Smalltalk. The big idea is messaging. That is what the kernel of Smalltalk, Squeak, is all about. Smalltalk is a pure, object-oriented programming language, meaning that, unlike Java and C++, there is no difference between values which are objects and values which are primitive types. In Smalltalk, primitive values such as integers, booleans, and characters are also objects, in the sense that they are instances of corresponding classes, and operations on them are invoked by sending messages. A programmer can change or extend the classes that implement primitive values, so that new behavior can be defined for their instances. For example, to implement new control structures, or even so that their existing behavior will be changed. This fact is summarized in the commonly heard phrase, in Smalltalk everything is an object, which may be more accurately expressed as, all values are objects, as variables are not. Since all values are objects, classes themselves are also objects. Each class is an instance of the metaclass of that class. Metaclasses in turn are also objects, and are all instances of a class called metaclass. Code blocks, Smalltalk's way of expressing anonymous functions, are also objects. Reflection. Reflection is a term that computer scientists apply to software programs that have the capability to inspect their own structure. For example, their parse tree or data types of input and output parameters. Reflection was first primarily a feature of interpreted languages such as Smalltalk and Lisp. The fact that statements are interpreted means that the programs have access to information created as they were parsed and can often even modify their own structure. Reflection is also a feature of having a meta-model as Smalltalk does. The meta-model is the model that describes the language itself, and developers can use the meta-model to do things like walk through, examine, and modify the parse tree of an object, or find all the instances of a certain kind of structure. Smalltalk 80 is a totally reflective system, implemented in Smalltalk 80 itself. Smalltalk 80 provides both structural and computational reflection. Smalltalk is a structurally reflective system whose structure is defined by Smalltalk 80 objects. The classes and methods that define the system are themselves objects and fully part of the system that they help define. The Smalltalk compiler compiles textual source code into method objects, typically instances of compiled method. These get added to classes by storing them in a class's method dictionary. The part of the class hierarchy that defines classes can add new classes to the system. The system is extended by running Smalltalk 80 code that creates or defines classes and methods. In this way, a Smalltalk 80 system is a living system, carrying around the ability to extend itself at runtime. Since the classes are themselves objects, They can be asked questions such as, what methods do you implement? Or, what fields, slots, instance variables do you define? So objects can easily be inspected, copied, serialized and so on with generic code that applies to any object in the system. Smalltalk 80 also provides computational reflection, the ability to observe the computational state of the system. In languages derived from the original Smalltalk 80, the current activation of a method is accessible as an object named via a pseudo-variable. This context. By sending messages to this context, a method activation can ask questions like, who sent this message to me? These facilities make it possible to implement coroutines or prologue-like backtracking without modifying the virtual machine. The exception system is implemented using this facility. One of the more interesting uses of this is in the Seaside Web Framework, which relieves the programmer of dealing with the complexity of a web browser's back button by storing continuations for each edited page and switching between them as the user navigates a website. Programming the web server using Seaside can then be done using a more conventional programming style. An example of how Smalltalk can use reflection is the mechanism for handling errors. When an object is sent a message that it does not implement, the virtual machine sends the object that does not understand message with the reification of the message as an argument. The message contains the selector of the message and an array of its arguments. In an interactive Smalltalk system, the default implementation of does not understand is one that opens an error window reporting the error to the user. Through this and the reflective facilities, the user can examine the context in which the error occurred, redefine the offending code, and continue, all within the system, using Smalltalk 80's reflective facilities.